How to find the mass percent composition of a compound. Percent means parts per 100 parts. The percent composition of a compound is the mass percent of each element in the compound. For example, let's say, look at this problem. What is the percent by mass of chlorine in calcium chlorate? Now, calcium, if you look at the formula of calcium chlorate, calcium, one molecule of calcium chlorate is made up of one atom of calcium, two atoms of chlorine, and 3 times 2, 6 atoms of oxygen. Now, what is the atomic mass of calcium? 40. Chlorine atomic mass is 35.5 times 2 will give you 71. Oxygen atomic mass is 16. 16 times 6 is 96. So the point is, calcium chlorate is made up of calcium, chlorine, and oxygen. There is some percent of calcium, some percent of chlorine, and some percent of oxygen in it. Question is, what is the percent by mass of chlorine? For that, first you calculate the molar mass. Molar mass means the mass of one whole mole. So for that, you add all the atomic masses. 6 plus 1, 7, and this is 207. Now, if you have to find out percent by mass of chlorine, what you have to do is just pick the mass of chlorine, which is 71, divided by total times 100. And this one will be 34.3%. Instead of chlorine, if you have to find out mass percent of oxygen, you're going to take 96 divided by molar mass, which is 207, times 100. The next topic is empirical formula. What is the empirical formula? It is the simplest formula giving the smallest whole number ratio. For example, let's look at these through 4 or 3 C2H4, C3H6, C4H8. The C2H4 is ethene, C3H6 is propene, C4H8 is butene. 3 different compounds. Can we change them to the simplest formulas? Simplest is the formula means smallest whole number ratio. If I divide this by 2, it will be CH2 will be the smallest whole number ratio. Smallest whole number ratio, smallest whole number ratio. That means all these 3 compounds have the same empirical formula but different molecular formula. Given the percentage of different elements in a compound, you can find out the empirical formula. What we have to do is look at this problem. What is the empirical formula of a compound that consists of 39.99% carbon, 6.73% hydrogen, and 53.28% oxygen? Solve this in a table form and just remember the steps, you will never make the mistake. In the first column, write down all the elements present: carbon, hydrogen, and oxygen. In the second column, what do? You write down the percentage in terms of grams. Assume a definite starting quantity 100 gram of the compound. What it means, assume 100 gram of the material. Then we can say, okay, 39.99 grams is carbon, 6.73 grams is hydrogen, and 53.28 grams is the oxygen. In the next column, write down their atomic masses. Carbon is 12, hydrogen is 1, oxygen is 16. In the next column, you're going to calculate moles. And how are you going to do that? You're going to do 39.99 divided by 12, which will come out 3.33. 6.73 divided by 1, 6.73. 53.28 divided by 16 will be 3.33. These are the moles. The last column is where you write down simplest whole numbers or the simplest ratio. How do you do that? In that case, you take the smallest number out of these three and divide each number by that number. The smallest out of these three is 3.33. So you're going to divide each of these number by 3.33. So what will be that? 1, 6.73 divided by 3.33 will be 2, and here 3.33 divided by 3.33 is 1. So your empirical formula will be C1, and we don't write 1. If no number is written, is assumed 1, H2O. So that's the empirical formula. One thing you have to keep in the mind at the very end, let's say we are doing a problem and the very end it comes out here 1 and 1.5, then in that case you have to multiply both the numbers by 2 to change it to this empirical formula. But this is, you do it only if your number on the very last column comes out 1.5. Now, empirical formula is the simplest formula. But what is the molecular formula? Molecular formula is the true formula representing the total number of atoms of each element present in one molecule of the compound. Now, two or more substances, they can have the same empirical formula but different molecular formulas. For example, I took this example on the last slide. These are two different compounds. So two different molecular formulas, but both of these have the same molecular formula. How do you find out the molecular formula? For that, first thing you need to know the empirical formula. So if the percentage is given to you, percentage of each element is given to you, you can find out the empirical formula. And then you find out the value of N, which is molar mass, that will be given to you in the problem, divided by the empirical formula mass. Once you have this N value, you take molecular formula equals empirical formula multiplied by this N value. So let's look at this problem here. Problem is, what is the molecular formula of a compound with the empirical formula CH and molar mass 26.04? So first your empirical formula is CH. You're going to calculate empirical formula mass. Calculate the mass of this empirical formula. Carbon is 12, hydrogen is 1, 13. And then you calculate value of N, which is molar mass divided by this empirical formula mass. Molar mass is given here in the question, 26.04 divided by empirical formula mass, which is 13. And this N is an integer. It has to be a whole number, which is 2. Then your molecular formula is empirical formula multiplied by N. Your empirical formula is CH multiplied by 2, which will be C2H2. So molecular formula is C2H2.
Made with Doodlecast Pro.